Good afternoon, class. This is practice test number 1, module 1, covering chapters 1, 2, 3. Here's chapter 2, exploring data and with tables and graphs. So we are given the frequency table. Answer the following question. The frequency table, it has the age group, for example, from 11 to 20, there are 5 of those. From 21 to 30, there are 6. 31 to 40 is 9, so on and so forth. That is a frequency distribution table. Sometimes they just call it FDT. We are interested in the number of classes. Well, notice this is 1, 2, 3, 4, 5. So 5 is the number of statistical age group defined, and therefore we have 5 classes. Class width. What is the class width? Well, it has a specific definition. The width is UL minus LL plus 1 unit. This stands for upper limit. This stands for the lower limit. For example, if you look at the very first group, lower limit is 11, 20 is upper limit. So this would be all the lower limits, and this column would be all the upper limits. So if you pick any class, for example, the first one, 20 minus 11 plus 1 unit. And the reason I say 1 unit, so 20 minus 11 plus 1 equals 10. Because the units may be 1, maybe 0.1, maybe 10,000. So 1 unit. That's one way to do it. The other one is that if you look at, so this is the formula I gave you, or the difference of 2 consecutive lower limits or upper limits. For example, if you look at this one, 21 minus 11, these two. If you look at this two, 51 minus 41. If you look at these two, 50 minus 40. Just pick any 2 consecutive lower limits or upper limits. So the answer is 10. The midpoint of the 4th class. So what is the definition or the formula for the midpoint? Lower limit plus upper limit divided by 2. We want the 4th class. This is what we want. So lower limit plus upper limit divided by 2 for the 1 plus 45 divided by 2. And that gives us the midpoint. (41 plus 50). Why did I put 45? That's the 4th class. My apologies. (41 plus 50). And that's 91 divided by 2. The lower boundary of the 5th class. So the way it works, if you want to find the boundaries, this is the process. I want it for the 5th class. So the lower limit of the 5th and the upper limit of the previous one, in this case 4th, you add them up, you divide by 2. 50 plus 51 divided by 2 is 50.5. So the answer is 50.5. And the process is to add these two numbers, 50 and 51 divided by 2. So the midpoint of the upper limit of the 4th class and the lower limit of the 5th class, add these two. And as long as you find one of those boundaries, then all you have to do, add the value of the width to get the next one and the next one and the next one. I'll show you on the next page. the upper limit of the first class. Remember, these are the lower limits. These are the upper limits. So what is the upper limit of the first class? Here's the first class, and 20 is the upper limit. So this is the upper limit, number 20. The sample size. Well, n equals summation of x. These are the x's, these are the frequencies. All we have to do, add them up. 5 and 6 and 9 and 11 and 4, we add them up and we end up with 35. So the answer is 35. Just wanted to have that fixed right here. All right. We are ready to move on. We're going to continue with the question. So we want the relative frequency of the first class. So how do we find the relative frequency? By definition, relative frequency is the amount of frequency of that class over the total size. So RF, short for relative frequency, is F over N. So whatever the F is for the specific class divided by total size N. We know N from the previous page is 35. The class width is 10, and this is the group. And I'm going to use it the same here because I want to actually fill up the tables. This is one easy way to fill up the table and write all the midpoints, boundaries, and so forth. So for this one would be F over N, 5 over 35. And 5 over 35 is 1 over 7. If they want it in decimal format, if they want it in percentage format, and you go with many decimals, you go with the number of decimals they ask you. Now, boundaries are the midpoint between the upper limit of one class and the lower limit of the next class, as it was mentioned in the previous case. So what I want to show you is that how we find the midpoint boundaries relative frequency. Relative frequency we already discussed for the first one is 5 over 35, which becomes 1 over 7. This would be 6 over 35, 9 over 35, 11 over 35, 4 over 35. As far as the midpoint, just add them up. For example, 11 and 20 divided by 2 is 15.5, and you do the rest of it. For the boundaries, we have found one, if you remember. So all you have to do, add these two, divided by 2, and you get the boundary, which is 20.5 for this one and this one. So you put 20.5 here, 20.5 here. And then all you have to do, add and subtract them. So here's the table, and I want to again explain the table, showing you how easy it is to find this. Starting with the midpoint, if you calculate the midpoint of the first class, which is 11 plus 20, that means 31 divided by 2 is 15.5. All you have to do, add the width. Add the width. You don't have to calculate again. Add the width, 10. So it becomes 25.5, 35.5, 45.5, 55.5. As far as the relative frequency, it has to be done one by one. But what about the boundaries? If you calculate this one, and let me just, when you calculate this one, just one calculation, which means adding these two and finding their midpoint divided by 2, right? 20.5. Then again, we said the width is 10. So add 10. Notice, add 10, 30.5, put it here. Add 10, 40.5, put it here. Add 10. Just add the width. What about the lower boundary of the first class? Subtract the width. So the calculation goes extremely fast. Find the model class and the mode. So if we have a frequency distribution table, FDT, how do we find that? So this is the model class. Why is that? the model class with the one with the largest frequency, class with the largest frequency. You look at the frequencies, this has the largest frequency. Therefore, this is the model class. So class number 4, which goes from 41 to 50 with largest frequency of 11. What is the mode? The mode is the midpoint of that class. The mode is the midpoint of the class, which is 45.5. The following frequency distribution table describes the speed of drivers ticketed through a 30 mile per hour speed zone. Calculate the relative frequency for all classes. So, as you recall, RF or relative frequency is F over N. So in this case would be 25 over the total size. In this case, 14 over the total size, 7 over that, 3 over that, 1 over that. Now, what is the total size? N is a summation of X, and we're going to add them up. And we get 50, 25 plus 14 plus 7 plus 3 plus 1. We get a total size of 50. I assume that's easy for everybody to do. So that's called relative frequencies now. 25 divided by 50, 14 divided by 50, and so forth. Now, of course, 25 divided by 50 is 1/2, 14 over 57 over 25, so on and so forth. If when you go with fraction, it's an exact answer. If you have to go to decimal, sometimes you may not find an exact decimal. You have to go with so many, decimals. You have to round them accordingly. That's why fractions many times may be a better choice. What percentage represents the speed of 53 miles per hour or less? Well, the essence is 53 or less. The essence is the cumulative frequency distribution of 53 miles per hour or less. And that would be these numbers. Just we want the percentage, or in essence, relative frequency. So we want this one and this one and this one. We add them up. Now 0.5, 0.28, 0.14, they add them up to 0.92, or just put 25 plus 14 plus 7. So we are looking at all those, okay, because this goes all the way to 53, right? So add those numbers and divide it by the total size of n equals 50. That gives you 92% either way. What are the class boundaries? Again, reminding you to find the boundaries. We find the midpoint between the upper limit of one class and the lower limit of the next one. So for example, these two will give us 45.5. So we're going to put 45.5 here, 45.5 here. Then, do we have to calculate the rest of them in the same manner? It's easier if we go with the width. The class width is 4. Why is that? I want to make sure everybody understands why the class width is 4. 45 minus 42 plus 1 unit. I hope you remember that. Or 46 minus 42. I don't know, 57 minus 53 as an example. Or let's say you go with these two and you say 61 minus 58 plus 1 unit? The answer is 4. And so now that we have the width, then all I have to do is just add 4 and I get 49.5 here. Same thing here. Then add 4, add 4. What about the lower boundary of the first class? Subtract 4, 41.5. So the calculation is really not too bad. All you have to do, just do one of them with details and the rest will fall into place. Nice and easy. So the same question, now we want part D. Construct a histogram corresponding to the frequency distribution table. Well, in order to come up with the histogram, we have a horizontal axis, we have a vertical axis. The vertical axis is easy. It's either the frequency or percent frequency. And what you want to do, you want to pay attention to this. You want to read this very carefully. Sometimes they say frequency, sometimes they say percent frequencies. They want the numbers, they don't want the percentage. So those numbers will be for the height on the vertical axis. But what goes on the horizontal axis? We have 3 choices. We can use the limits, we can use the midpoints, or we can use the boundaries. And we should have the same width. So boundaries are better choice because in some other graphs, such as ogive, we use the boundaries. So draw a horizontal line and let's just remind everybody what the boundaries are. So 41.5, 45.5, 49.5, so on and so forth. So the first one, 41.5 to 45.5, will have a height of 25. The second one will have a height of 14, so on and so forth. So take a look at how it looks like. We are going to use the boundaries. Again, you can use limits. You can even use midpoints. But as I mentioned, in many cases, they use the boundaries. Now the height, 25 for the first one, the height, 14 for the second one, 7 for the third one, 3 for the fourth one, and 1 for the last one. This is the histogram. Now, the difference between a histogram and Pareto chart is that you're dealing with a numerical data here, and the bars are next to each other. They don't have to go from large to small. It just happened to be that way in this case, whereas in Pareto chart, we go in order. And the bars are connected. No distance, normally no distance between the two. What I want to add is this. In order to find the width from the histogram, if limits are given, the width is calculated as follows, and we do not add 1 as explained before. Upper limit minus lower limit, or UB minus LB, the upper boundary minus lower boundary. If you recall, when we have the frequency distribution table, we say 45 minus 42 plus 1. That's not the way it works if they happen in some text, if they happen to give you the histogram in the exam. In essence, we are looking at the same problem as before, and now we are adding the following questions. We want to come up with a cumulative frequency distribution, and then relative frequency distribution. So basically, I want you to concentrate on this word and the meaning of that. Cumulative means the whole from the get-go. So what happens is that all of this, if you look at, I want you to look at the very first column, and starts from 42, goes to 45, so on and so forth. But when it comes to cumulative, you start from the very first one, 42, in each and every one of them. Again, there are other ways I'm going to discuss it, but this is the fastest and best way. So all of them, the initial value, the lower limit will be 42. So all of them change the lower limits to the lower limit of the first class because of this fold. That's the reason. So what happens? This remains the same. But what happens here, you have to add this to 25 plus 14. What happens here, 25 plus 14 plus 7, all the way to the end. So basically, you add in a manner that the very last one must give you n. If it doesn't, we've made a mistake somewhere. So the last one is 50. Now, as far as the second part, cumulative relative frequency, the process is the same, f over n. So we divide this one by 50, then this one by 50, this one by 50, this one by 50, and the last one must always be either 1 or 100%. The last one is always 1 or 100%. And again, I'm going to remind you that you do have these solutions in essence on Canvas in the form of a Microsoft Word. So cumulative means the lower limits remain the same as the lower limit of the first class. And as far as the frequency, we add them up. So the last one must be equal to n. For the cumulative relative frequency, we follow the formula f over n, and the last one must be 1 or 100%, because they may ask you for cumulative relative frequency or percent frequency. In essence, it's the same thing. Percent frequency means the same thing here. All right. Now, we are looking at the same question, part C. Okay. The following frequency table describes the speed of drivers to get through a 30 miles per hour speed zone. Draw an ogive of the cumulative percentage distribution. So we're going to go with the percentage. And so when we go with the percentage, we had this, and we use the boundaries from question number 2. Okay, so I hope you remember that. Or simply put, if you go back to the previous page, it started with 46 here. I hope you remember that, not the cumulative one, the frequency distribution table. So 45 and 46, add them up, divide by 2, you get 45.5, and then add and subtract the bit for the rest. So anyways, or you can go back and find this from the previous question. And now that we have that, we are going to put the boundaries here, 41.5, 45.5, all the way to 61.5. And we're going to put numbers here. And because we want percentage, we're going to go from 0 to 100. I mean, I have even 120, but you know, we want to go from 0 to 100. What is very important to know that the lower limit of the first class corresponds to 0, the lower boundary. The upper boundary of the last class corresponds to 100% or 1. So I want to make sure we understand. So the first one, this must always correspond to 0. And the last one must correspond to, this is 100%. everybody, okay? 100% or 1. The next one, this is 50%, so it corresponds to 45.5. So 45.5, 50%. 49.5, 78%. Roughly, may not be exact. For the 53.5 now, 53.5, 92%. Okay. This is 4.78%, so the numbers are not scale. Okay, so this one, 40.5 is here, 70%. Okay, 53.5 is 92%. And 57.5 is 98%. It's pretty hard to show. Now, you connect them with line segments like so. Okay, that's how you connect them. Let me show you, of course, a better picture. So before I do that, again, I want to make sure everybody understands what's going on. The lower boundary always corresponds to 0. This is 0. The upper boundary of the last class always corresponds to 1 or 100%, and then in between. So 45.5 corresponds to 50%, and so on and so forth. And here's the graph. Let me just clean up. It makes it easier to see a more precise answer. Now, what is it good for? The following type of question. Using the OJI, find the percentage of drivers who drove 47 miles per hour or less. So we are going to locate 47 along the horizontal axis. And corresponding to that, we find the value along the vertical axis. And it seems to be at about 60%. Number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%. Therefore, 60% to 61% of drivers drove 47 miles per hour or less, according to the OJI. The ages of 40 tenured faculty at CSULB, N equals 40 ages, are given as follows. Construct a dot plot, construct a stem plot, or stem and leaf plot as it's called. So let's see what we are doing here. First, let's look at the definition. A dot plot is a graphical display of data using dots for relatively small data sets, where values fall into a number of discrete values or categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as a stack of dots. So the very first thing we have to do is to rank this. And I put this in red and I put this in blue to say this is the smallest number, This is the largest number. We are going to rank this first. So we're going to sort them from the smallest to largest. So the first step, rank the data. Now we are going to have a horizontal line. You can think of it as a number line. And we are going to put the numbers from 32 to 63 along the horizontal line, a number line, x-axis, whatever you want to call that. Okay. So we go somewhere from 32 to 63. And then we start putting the dots. For example, 32, I have only one piece of data with a value of 32. So somewhere here, remember this is like 37.5. So that means, we have to go a little bit. So here I put a dot, right? So I put number 32 here and I put a dot here. 37. So 30, this is 37.5. So 37 is here. I put a dot here. 39 somewhere here, I put a dot. 40, I put a dot. 42, 43, 45. So we put just one dot. When we hit, let's see what number. 47. Okay. 47. So when we locate 47 somewhere here, then we put 1 and 2 dots. 1 and 2 dots. You need to put 2 dots. 48, you put 1. 49, you put 1. And 50, you put 1. 51, again, we put 2 dots. 52, we put 1. And then 53, somewhere here, we put 1, 2, 3 dots. So it looks like this. Take a look. Clearly, the ages range from 32 to 63 years. Okay, from 30 to 63, clearly. Also, there is more tenured faculty at older age. Take a look. We have more dots here. So that's what it shows. More tenured faculty at older ages. That's the purpose of that, to give us some sort of information. We're going to repeat the question, and this time part B is the same question. We're going to construct a stem plot or stem and leaf plot. And I'm just putting the sorted or ranked one from smallest to largest one. So this was given, this we came up with. So we're going to use this one that we came up with for this question. So again, definition. Stem plots. Stem and leaf plot displays the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value digits to the left and one leaf to the right. We can see the distribution of the data while keeping the original data values. So I hope that's clear to everybody as to what's going on. So let's look at the numbers. The numbers, we have 2 digits. So the leftmost digits are 3, 4, 5, 6. Now, if you look at this one, we have 32, 37, 39. So right in front of that, we're going to put 279. If you look at this group, they are in 40s. So in front of 4, we're going to put 0, 2, 3, 5, 6, 7, 7, 8, 9. So take a look. 0, 2, 3, 5, 6, 7, 7. You have to repeat it. If it repeats 10 times, you have to repeat it 10 times. 8, 9. And I'm going to assume everybody can figure out the rest again in the same manner. So in front of 5, I would put 0, and then 1, 1, 2, 3, 3, 3, so on and so forth, and do the same thing for number 6. This is for number 5. For number 6, we would put 0, 0, 1, 1, 2, 3, 3. And again, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages.